Hello, this is Chris Tae-yoon Kim from South Korea, who is a current postdoc researcher at Kasasan University, Bangkok, Thailand. Today, I would like to give a short talk about my ongoing research topic, developing cost-effective spatial repellent tools. In this study, we tested the efficacy and persistency of transfluthrin and metofluthrin with various fabrics using high-throughput screening system. Let me start. Dengue infection is a global burden, but most of the cases are in Asian countries. For example, in Vietnam, dengue cases were boosted up to 5 times in this year. A recent report from IPCC Climate Change Panel meeting, geographical distributions of the dengue vector is threatening vulnerable people more seriously. Aedes abundance prediction map is showing wide coverage of the dengue vector mosquito over the world. Billions of vulnerable people are on the risk of the tropical mosquito vector-borne diseases, such as dengue and Zika viruses. To avoid the mosquito-borne vector-borne disease infection, inhibiting human and vector contact is a key intervention during daytime, especially for the outdoor activities. Mosquito coil is one of the traditional spatial repellents have used for several decades. However, it has limited protection time and fixed coverage, also not appropriate to carry it into the forest. There is another format, so-called spatial repellent emanator, which has portable cartridge type and longer lasting up to 30 days. It is specially designed for the outdoor activities such as camping or fishing. However, high price is another burden to the forest goers for their daily life. So, cost-effectively long-lasting spatial repellent tools are urgently necessary. Water hyacinth is top 10 weed in the world. In Thailand, this invasive plant is a big problem with rapid fertility under the tropical climate. This plant is not only interrupting operations of ships or boats, but also damaging the other aquatic organisms such as fish. So, Thai government sends troops to remove these problematic weeds every season. On the other hand, traditionally, people in the Southeast Asian countries have used the water hyacinth as one of textile materials. This notorious weed may turn into tools for protecting people from mosquito bites by impregnating spatial repellents on it. As you can see on the screen, the water hyacinth products are easy to find in Thailand and other parts of the world. As most of products are portable or wearable, end users carry it outdoors during daytime, so it will be worth to apply the water hyacinth fabrics to spatial repellent tools. To explore two main spatial repellent activity integrants, namely transfluthrin and metofluthrin. First, we generated discriminating concentrations using toxicity assay. Second, based on the discriminating concentration, compare the spatial repellency between two chemicals using contact and non-contact irritancy assays. Finally, persistency of different types of textiles were compared by impregnating the discriminating concentrations of each transfluthrin and metofluthrin. Experiments conducted using two phenotypes of pyrethroid susceptible and resistant Aedes aegypti mosquitoes. Technical grades of metofluthrin and hanging guard fabrics were provided by Earth Corporation Japan and Earth Thailand Company. Two natural fabrics were obtained from Thai local market. Three modular cylindrical tropical high-throughput screening system was used for toxicity, contact, and non-contact irritancy assays. Detailed methodology for spatial repellent is well described in WHO guidelines. To obtain discriminating letter concentrations, two-fold serial dilution has conducted to prepare 5 testing concentrations from 0.0017 to 0.017 for both chemicals using toxicity assay. At 0.008% and 0.017% of metofluthrin resulted 100% mortality against susceptible Aedes aegypti, but it was less in transfluthrin. Now, let's talk about discriminating concentrations of each chemical. Briefly, toxicity assay has a single treated chamber. 20 non-blood-fed 3 to 5 days aged female mosquitoes were introduced into the chamber for an hour exposure. Total 6 replicates were conducted. After completing an hour knockdown counting, all the mosquitoes were collected and placed into a plastic cups for 24 hours to check the mortality. According to the mortality data, probit analysis was conducted to calculate 50%, 75%, and 99% letter concentrations. The discriminating concentrations were obtained by doubling letter concentration of 99%. Table shows discriminating concentrations. Transfluthrin shows 5 times higher DC than metofluthrin. However, there was no significantly different percent mortality between transfluthrin and metofluthrin. Next, behavioral responses of Aedes aegypti against discriminating concentrations of each chemical were evaluated using contact irritancy assay. It is consisted of 2 modular cylinders, treated and receiving chambers, to counting number of the escaped mosquitoes. 10 mosquitoes introduced into the treated chamber and opened a small-sized butterfly door between 2 chambers to allow mosquitoes freely escape from the treated to the receiving chamber for 10 minutes. 6 replicates were conducted for the CIA. Results show that percent knockdown and mortality from 0.15% transfluthrin were significantly higher than 0.03% metofluthrin. Less knockdown enhanced more escape, so metofluthrin resulted significantly higher percent escape. In other words, the escaping rate was inversely proportional to concentration, as higher concentration resulted in higher knockdown and mortality, so that lower numbers of mosquitoes escaped. This is a common sense. However, the spatial repellent assay showed different results. 20 female mosquitoes introduced in the middle chamber and opened both sides of the butterfly doors for 10 minutes to make the mosquitoes freely fly into all the 3 cylinders to count number of mosquitoes from each chamber. Spatial activity index was calculated using a formula on the screen. 9 replicates were conducted for this spatial repellent assay. Interestingly, 0.03% metofluthrin resulted in significantly higher knockdown and mortality compared to the 0.15% of transfluthrin. However, spatial activity index was in direct proportion to concentration, so that higher concentration of transfluthrin resulted significantly higher spatial activity index compared to the lower concentration of metofluthrin. This phenomena caused by the number of mosquitoes in treated chambers. The lower concentration of metofluthrin may not be enough to repel the mosquitoes from the treated chamber, so that there were significantly a greater number of mosquitoes that contacting the metofluthrin treated filter paper. It may result significantly higher percent knockdown. Meanwhile, higher concentration of transfluthrin successfully repelled mosquitoes from the treated chamber to middle or untreated chamber. In other words, the saturated treated chamber with a great number of transfluthrin particles may be beneficial to disperse. On the other hand, lesser numbered metofluthrin particles probably not enough to repel the mosquitoes from treated chamber. To sum up, a greater number of particles with higher concentration might be advantageous on spatial repellency compared to less numbered stronger unit particle toxicity, unlikely contact toxicity or irritancy. Based on results from the HITCH assay, decreasing patterns of percent mortality were observed from toxicity to contact irritancy assay to spatial repellent assay. Contact irritancy assay resulted demonstrated The results demonstrated percent mortality in direct proportion to concentration. For example, lower concentration of metofluthrin resulted in significantly lower mortality, and higher transfluthrin concentration caused significantly higher percent mortality. Meanwhile, in spatial repellent assay, the concentration is in inverse proportion to mortality. As mentioned in previous slide, lower concentration of 0.03% metofluthrin may have smaller number of particles in the treated chamber compared to 0.15 transfluthrin. So, less mosquitoes were repelled by metofluthrin from the treated chamber, and it caused more numbered mosquitoes had a chance to contact the highly toxic metofluthrin treated filter paper. Once again, higher concentration with a greater number of particles is advantageous for spatial repellency. To sum up, the mosquitoes' behavioral responses were obviously dose-dependent, and it can be observed optimized concentrations between knockdown and repel for the hitch assays. So far, we established discriminating concentrations and observed behavioral responses using the three-modular high-throughput screening system. Number one, toxicity assay confirmed that metofluthrin was 4.7-fold more toxic than transfluthrin, so that discriminating concentration were 0.03% for metofluthrin and 0.15% for transfluthrin. Number two, contact irritancy assay demonstrated dose-dependent behavioral responses that higher concentration resulted higher percent knockdown, so that less escape rate. So 0.15% transfluthrin resulted significantly higher percent knockdown compared to the 0.03% metofluthrin, so that metofluthrin resulted significantly higher percent escape. However, the 0.15 transfluthrin in the non-contact irritancy assay resulted significantly less percent knockdown, but significantly higher spatial activity index, which means spatial repellency. Regarding its different mechanisms between contact irritancy and spatial repellency, higher concentration of transfluthrin vapor may fully saturate treated chamber compared to the lower concentration of metofluthrin. So the transfluthrin vapor may affect more to mosquito behaviors than metofluthrin. To sum up, those hitch assays successfully demonstrated dose-dependent behavior responses of Aedes aegypti. Now, let's move on to the fabrics. Discriminating concentrations of each transfluthrin and metofluthrin were impregnated on two natural fabrics to compare persistency with a commercial product, hanging guard. All the 0.3% metofluthrin and 0.15% transfluthrin treated fabrics were washed up to 25 times, following the standard washing protocol described on the screen. 0.15% transfluthrin and 0.03% metofluthrin treated fabrics were compared using toxicity assay. The results show that all fabrics persisted over 80% mortality against susceptible Aedes aegypti up to 25 washes, except hanging guard. In addition, toxicity between chemicals was not significantly different except Pacra soap at 10 and 15 washes, and it demonstrated dose-dependent persistency effect between 0.15% transfluthrin and 0.03% metofluthrin. Dose-related persistency is much clearly described in the next slide. Line graph showing percent mortality according to number of washes for each fabrics for 0.15% transfluthrin and 0.03% metofluthrin. Transfluthrin impregnated natural fabrics persisted its mortality over 80% up to 25 washes. However, the synthetic fabric significantly dropped the percent mortality after 25 washes. For the 0.03 metofluthrin, all the fabrics dropped the percent mortality before 25 washes. In summary, persistency of the spatial repellent treated fabrics also dose dependent. However, two natural fabrics, Pakrasov and water hyacinth, treated with transfluthrin showed significantly higher mortality at 25 washes compared to the synthetic fabric. To develop the cost-effective intervention tools, we explored alternative natural textiles, and there are three major concerns agree with WHO recommendations. First, standardized protocols. Second, cost-effective. And last, long-lasting. In this study, we confirmed the high potential of the transfluthrin impregnated natural textiles. For the commercial product, hanging guard fabric, however, although persisted 100% mortality up to 15 washes, it was significantly dropped at 25 washes. To satisfy the WHO recommendation, we suggest to retreat the synthetic fabric at the dropping point. This picture shows the quality of the fabrics after 25 washes. Both natural textiles were damaged badly after multiple washes, while the synthetic fabric maintained its original condition very well, so that it seems like appropriate to retreat active ingredient to enhance efficacy and persistency. Retreatment would make the commercial product turn into reusable, cost-effective, and longer-lasting spatial repellent. Conclusion. The heat toxicity assay successfully generated discriminating concentrations for metofluthrin and transfluthrin. Subsequently, behavioral responses of Aedes aegypti were observed using contact and non-contact assays. Finally, cost-effectively long-lasting spatial repellents could be developed by using natural fabrics. In addition, the commercial product hanging guard can be reused by retreating at the efficacy dropping point. Overall, higher concentration of transfluthrin is more stable than lower concentration of metofluthrin for especially spatial repellency and also persistency. Next steps would be semi-field and open-field trials. Encapsulated chemicals on local fabric products will be tested. Additionally, spatial repellents post-exposed female mosquitoes will be observed, the impact on their biological parameters. I sincerely thanks to my supervisor, Professor Tirapap, Charyonbiriapap, and mosquito lab members for providing testing mosquitoes. Research funding sources, Kasasan University Research and Developed Institute, and Reinventing University Program. Mr. Atarasi from Earth Corporation Japan and Mr. Fujikawa from Earth Thailand Company for providing hanging guard fabrics and metofluthrin. Last but not least, thanks for kind feedback on spatial repellent study, Dr. John Glico and Dr. Nicole Achiu. Thank you very much for your listening my talk today, and I hope to see you all in Chiang Mai next year. Kokun Kap.